Stars are the small glowing and twinkling dots that we see in the night sky. In reality, however, stars are ginormous. They only seem small because of how far away they are. It takes 8 minutes for light and energy from our sun to reach us. That also means that if the sun were to suddenly disappear, we wouldn't actually know for 8 minutes. In fact, the closest star to our solar system besides our sun is Proxima Centauri. It is over 4 light years away. Now, a light year is the distance light travels in a year, which is approximately 10 trillion kilometers. Since it takes 4 years for the light from our closest star to reach our sun, when you look at Proxima Centauri through a telescope, you're basically looking at a picture of what a star looked like 4 years ago. So what exactly is a star, and what are stars such as our sun made of? A star is basically a large fiery ball of gas, which works as a nuclear powerhouse powered by the fusion of hydrogen atoms, the most abundant element in the universe. Nuclear fusion is the process of 2 atomic nuclei joining to become a third enlarged nuclei. In a star's case, it uses hydrogen as fuel to produce helium, the same element which is used to make balloons float. This process releases tons and tons of energy, which is what powers stars. This is actually the same process which is used by hydrogen bombs, except stars like our sun use nuclear explosions of a much higher scale. In fact, the amount of energy being produced by our sun is equivalent to about 2 billion hydrogen bombs exploding every second. We know what stars are made of because of a process called spectroscopy, which is basically passing light through something like a prism to break the light down into its constituent colors. Every element present emits a different color, so we can see exactly which elements are present in a star. Now, you might be wondering how such massive blazing nuclear reactors are made and come to be. Stars are formed from nebulas, which are interstellar clouds of dust, hydrogen, helium, and other elements, which look like large, colorful clouds in space. As the gas and dust in the nebulas begin to clump together, the nebula begins to collapse due to its own gravity. As the cloud begins to collapse, the density and temperature quickly increases. As the nebula begins collapsing, increasing this new star's mass, the gravity increases until the core of the new star is powerful enough to start fusing hydrogen. Star life cycles last billions of years. Stars lose their supply of hydrogen and enter the stages of their life which result in their death. The death a star will experience, however, depends on the size of the star. Smaller stars, such as our sun, die by going through a red giant stage. As a main sequence star that is smaller than average, much like our sun, starts to run out of hydrogen fuel, it will start to contract under the weight of gravity. However, hydrogen fusion will occur in the upper layers, which will cause the star to expand. As it expands, the star runs out of hydrogen fuel, but at this point the core is hot enough to fuse helium into carbon. When the helium fuel runs out, the core will also expand and cool. Finally, the core will cool into a white dwarf and eventually a black dwarf. This process alone takes a few billion years. Our universe is said to be only 13.8 billion years old, and a black dwarf would take longer than that to form. We believe to know the approximate age of the universe today from measurements of nearby and distant galaxies, particularly their rates of expansion away from us or how fast they are moving away from us. A black dwarf is just what scientists believe to be the remains of a star when it has no energy left to emit, but still possesses mass. Stars that are more massive than our Sun, however, die much more violently. At first, when a massive star's hydrogen fuel begins to run out, it too starts fusing helium into carbon. But, unlike smaller stars, it doesn't start expanding. Instead, the core is hot enough to even fuse carbon into heavier elements. In fact, some stars are powerful enough to start fusing elements into iron. Once the core has become an element such as iron, the star can no longer burn like a candle the way it used to. Instead, the star collapses onto itself. In less than a second, the star's gravity becomes so powerful that the entire star shrinks so much that it creates an area of unimaginable energy. Less than a second later, it explodes into what is considered the biggest explosion possible in the universe today, a supernova. After the supernova, the remaining mass is used in one of two ways. The leftover mass forms a neutron star. Neutron stars are the densest and tiniest stars known to exist in the universe. Even though they only have a diameter of about 10 kilometers, one spoonful of a neutron star would weigh 5 billion tons. Some supernovae, however, become so large that they turn into black holes. Black holes are so dense that their gravity sucks in anything near them. Not even light can escape its surface. And that is the life and death of a star.